more about why we might start indexing at 0, because it's pretty fundamental to the way in which we implement algorithms, and it's important that you understand it at a basic level. So in general, when we begin counting in algorithms, we generally start from 0, and this is because before we start counting anything, we have 0 things. So imagine if we're counting cards that are laid out on a table one by one. We generally start counting once the first card has been laid down, but there's a sort of implicit assumption that before we start, there's some counter that doesn't yet have a value, or it has a value of 0. Now, of course, in computer code, having things with undefined values isn't a good idea, and we need to be explicit. So we explicitly say that the counter starts at 0 and is then updated as soon as we create an item or lay a card down. Okay? So another way to visualize it is in terms of the memory blocks that we allocate to an array. So if the start of the block is denoted by this line here, then the first element in the block, or in the block of the array, is 0 distance away from the starting point. So if this is our first element here in the array, if this is the starting point, then this first element is located 0 distance away from the starting point. So it gets the index, or location, if you like, of 0. So there's an important point here in that if we start indexing at 0, then we need to remember to stop indexing an array at a value that is 1 less than the number of items in the array. So if we have 5 elements, for example, we index them as 0, 1, 2, 3, and 4. If we try to index item 5, then that's essentially a 6th element, which has gone over the boundary of the array. So more generally, for any array of size n, they get the indexes of 0 to n minus 1. And if we try to break this rule, the system will complain, as we see here. So notice how we've tried in the for loop to index not less than num students, but less than or equal to num students. So we essentially go from 0 to 20. Now 0 to 20 is 21 items rather than 20. So here we've sort of stepped out of bounds of the array, and processing is telling us precisely that. It's saying that the array index is out of bounds, and an exception just means an error. So it even tells you what the rogue value is, 20, here for good measure. So this is quite a common error, and when you get it, make sure that your termination condition of your loop is set up correctly so that you're not trying to step one over the boundary of the array.